Okay, we're going to do a quick little lesson on unit vector notation. So a vector, as we should know, is a measured quantity with specific direction. So, for example, displacement is a vector. A displacement could be something like 25 meters east or 73 meters north or 16 meters southwest or something like that. So with unit vector notation, it gives us a way to tell the direction of a vector with a standardized set of coordinates. So, for example, we take our x, y, and z three-dimensional coordinate system, and we turn it into an I, j, and k system. So the unit vector is simply a multiplier, right? So if we look at this arrow, for example, this arrow, we're going to use units of meters. We're going to assume that each box is a meter here. So this line, this arrow, is 5 meters long. Now, if I want this to be a vector, right, I can multiply this by what we call the unit vector, the I unit vector. And when I say 5 meters I hat, we now all understand that this vector, if I say 5 meters I hat, you know how to draw that. You know that you have to draw a line pointing to the right across the page in the positive x direction with a length of 5. Okay. Now contrast that with this one here. This would be 2 meters, but it's to the left, right? So this would be in the I direction, but in the negative I direction. So we multiply this by the unit vector negative I, which makes it minus 2 meters I hat. And again, we all know exactly, we could all agree that we understand exactly what negative 2 meters I means. It means you draw a vector 2 meters in the negative x direction. So this one here would be also 2 meters, but notice that this points up along the page this way, which would be the positive y direction. So we say that this is positive 2 meters j hat. Okay. Now we don't use the k vector very often in the AP class. We mainly stick to I and j. We mainly deal with two-dimensional systems. You can deal with three-dimensional systems. There are applications for the k vector. We just don't use it very often in this particular class. So if you look at this vector here, well, how would you specify this using unit vector notation, right? It points both to the right and up. Well, how much to the right and how much up is it? Well, we can figure that out because we have a distinct set of boxes here, right? We can count the boxes. This process can be a little more complicated if we don't have the boxes, but we can all agree that this guy has 3 meters in the positive I direction and 3 meters in the positive j direction. So this guy in unit vector notation, we could say is plus 3 meters I hat plus 3 meters j hat. So notice that this unit vector notation is essentially a code for constructing the vector. And we can do this backwards as well. So if you wanted to look at this one, we would say that this vector in unit vector notation is minus 4 meters I hat plus 1 meter j hat. Okay, again, this is just a very brief introduction to unit vector notation. As we use it and develop it, you'll see how this is useful and applicable. And the idea that having a standardized notation for I, j, and k, rather than relying on cardinal directions, is actually really advantageous because all of a sudden it doesn't matter if it's north, south, east, and west. We can just pick a direction and call it the I direction, and we know that the J and K directions are at 90 degrees to whatever that is.